So for the problem below, we want to determine if Rolle's theorem can be applied, and if it can, find the C values that satisfy it. If it cannot, explain why. So remember, Rolle's theorem has the same hypothesis as mean value theorem. So first we have to state y is continuous on the closed interval negative pi to pi, and we know so because it's a trig function. Y is differentiable on the open interval negative pi to pi because it's a smooth trig curve. So now the extra hypothesis is checking the endpoints. So y of negative pi is negative 2 cosine of negative 2 pi. Remember, cosine is an even trig function, cosine and secant, so that's negative 2 cosine of 2 pi, which is negative 2. And y of pi is negative 2 cosine of 2 pi, which is negative 2. So we have shown that y of negative pi equals y of pi. So now that we've checked all hypotheses, 1, 2, and 3, we can say by Rolle's theorem, there exists a C value within the interval negative pi to pi such that f prime of C equals 0. So we don't have to do the average rate of change. So now what we can do is solve for that C value. So now we're going into the idea that f prime of C equals 0. Well, f prime of C is going to be positive for sine of 2c equals 0. So sine of 2c equals 0. So 2c equals sine inverse of 0. So now, a little caveat, remember that originally we're looking for a C between negative pi and pi, but now we're solving for 2c. So 2c, we're looking for everything between negative 2 pi and positive 2 pi that satisfies sine inverse of 0. So 2c equals, well, we know sine inverse of 0 is at 0. We also know it's at positive and negative pi. And we also know it's at positive and negative 2 pi, but we're not going to use those because we don't want to equal our endpoints. So now if I solve for C, C equals 0 and positive or negative pi over 2. So that's our C values. And here are the 1, 2, 3 hypotheses for the Rolle's theorem and our overall conclusion from it.